So here in this video we are going to see the miscellaneous exercise for chapter 6. Okay, so under this miscellaneous exercise, if you see, mostly the last exercise, that is exercise 6.5 we did, no? So related to that problems as well as some maxima minima problems are there under the miscellaneous exercise here. So I'll start with the second question. Show that the function is said to be given by f of x is equal to log x by x has maximum at x is equal to e, it is given here. So you'll have to show that it has got a maximum at x is equal to e, means you know by the second derivative test is what I'll have to show here. So what is the second derivative test here? I'll have to differentiate it with respect to x. So in order to differentiate it with respect to x, I'll have to use the u by v formula. So your f dash of x is equal to x into differentiation of log x will give you 1 by x minus log x into differentiation of x, that's nothing but 1 divided by x squared. So here if you see, your x and x gets cancelled, so you're left with 1 minus log x divided by x squared. You understood? So here if you see, your f dash of x is equal to 0, so you get 1 minus log x divided by x squared is equal to 0. Cross multiplying, you will have it as 1 minus log x is equal to 0. So in that case, what will you get? Log x equal to 1. So if your log x is equal to 1, it means that you know that log of e to the base e is nothing but equal to 1. So in that case, what is your x equal to? Actually, your x is equal to e. Okay. So what's the next step I'll have to do here? I'll have to find out the second derivative with respect to x here. So here your f dash of x is 1 minus log x divided by x squared. So differentiating it again, what will I have here? The numerator, that's nothing but x squared into differentiation of the numerator. Differentiation of 1 will give you 0 minus differentiation of log x is what? Minus 1 by x plus 1 minus log x into differentiation of the denominator. What will you have here? It's nothing but 2x divided by x squared the whole square. That's nothing but x power 4. Now here when your f double dash of x at x is equal to e. So here when I substitute x is equal to e, here if you see gets cancelled here. So I left with minus e plus 1 minus log of e into 2e divided by e power 4. This is what you have here. So log e to the base e is nothing but equal to 1. So this whole thing it becomes 0. So you are left only with minus e by e power 4. So what is it? It's obviously less than 0. Therefore what can I say here? Your f of x has got a maximum at x is equal to e. So I have already told you here under the second derivative test, the exact value is not needed here. Either it is greater than 0 or less than 0. Only that part is needed here. So that is what you'll have to do here. Okay. Now coming over to the next one here, the 8th question. Find the maximum area of an isosceles triangle inscribed in the ellipse x squared by a squared plus y squared by b squared equal to 1 with its vertex at one end of the major axis. Okay, with its vertex at one end of the major axis. So find the maximum area of an isosceles triangle. So here you know the meaning for an isosceles triangle here, where even you have your two sides to be equal, angles to be equal, etc. here. Okay, inscribed inside an ellipse. So it is inscribed inside an ellipse here with its vertex at one end of the major axis. So here if you see, you have got an isosceles triangle here. Okay, so here if you see the vertex, if you see here the vertex of this one, it's said to be one end is said to be at the major axis. So here you know this is your major axis and this is the minor axis. So what are the points you have in the major axis here? A comma 0, in the minor axis you have it as 0 comma b. So I have inscribed an isosceles triangle here. So this is the isosceles triangle you get in this case. So here one vertex is said to be at the major axis according to the question. Okay, so I'll have to show that it has got the maximum area. What is to be proved actually, or it has got the maximum area. This is to be proved here, and of course it is inscribed in a triangle, ellipse. This is all is given here. Okay, now here we'll start with the part. So here I've just taken, let this OD be equal to x, so that this vertex will be what? X comma 0, you know here. This is nothing but a comma 0. Got it? Now what is this length actually here? This length will be nothing but equal to 2y. That is your BC will be equal to 2y. So what is your BC actually here? Your BC is nothing but the base of the isosceles triangle. What is this length AD? That's nothing but the height of the isosceles triangle. Why am I taking the base and height? Because you know what is the area of the triangle equal to? Half into base into height. Because in the question they have asked us the maximum area of an isosceles triangle. Got it? So here I have written it as half into base into height. So it's half into, your base is nothing but equal to 2y. Okay, if you see here, this one will be y, here this will be y here, y plus y, that's nothing but equal to 2y into a minus x. Why is that I have written it as a minus x here? The total thing from OA, okay, so here OA will be equal to a. You know that your OD is equal to x here. So what is your AD equal to here? It's nothing but the whole thing minus this. That's nothing but equal to a minus x. That's what we have written here. That is your height of the triangle. As I mentioned it earlier itself, your BC is the base and AD is nothing but the height of the isosceles triangle. So here you have it as 1 by 2 into 2y into a minus x. So your 2 and 2 gets cancelled. You are left with y into a minus x. Okay, so this is your area. Now, of course, to find the maximum area, I'll have to do the second derivative test. But one problem I have y and x together. So I'll have to either bring it in terms of x or bring it in terms of y. So I'm going to make use of this equation given here, the ellipse x squared by a squared plus y squared by b squared equal to 1. So you will get y squared by b squared is equal to, taking it to the other side, it's 1 minus x squared by a squared. So here when I cross multiply, you are left with a squared minus x squared divided by a squared. So what is your y squared equal to? B squared by a squared into a squared minus x squared. Okay, so have this in mind now. Now we'll come back to here, a equal to y into a minus x. So now as I have taken the square root here, if I write it, it's difficult for us to differentiate it. Okay, the steps will be a little vague here, complicated one. So what I'm going to do here is I'm going to square both sides here. So when I square it, what will I get? A squared is equal to y squared into a minus x the whole squared. Okay, so what is your y squared equal to? B squared by a squared into a squared minus x squared. That's what I have written here. A squared minus x squared into a minus x the whole squared. Now this a squared, I have taken it to be equal to t, because I'll have to differentiate it with respect to x in this case. Therefore I just write it in terms of t. Finally we'll just say what is the area here. Okay, so now differentiating it with respect to x. So what is your t equal to? What did you have there? A squared minus x squared into a minus x the whole square. This is what you had. So I'll have to apply the uv formula here. So when I apply the uv formula, what will you get? dt by dx is equal to b squared by a squared into, so apply it, a squared minus x squared into differentiation of a minus x the whole squared. What will you get? 2 into a minus x into differentiation of a minus x. That's nothing but minus 1 plus a minus x the whole squared into differentiation of a squared minus x squared. What is that equal to here? It's equal to minus 2x. Got it? So here if you see this a minus x, first of all I have taken it out, as well as I have taken minus 2 common here. So it's minus 2 b squared by a squared into a minus x into, you're left with a squared minus x squared, okay, plus you have x here and 1 a minus x here. Now here again this can be written as a minus x into a plus x. Okay, a squared minus b squared formula. So again if you see here, a minus x is again common. So again if I take a minus x, you are left with minus 2 b squared by a squared into a minus x the whole squared. So you are left only with a plus x is what you have here. So what will you get? Minus 2b squared by a squared into a minus x the whole squared into 2x plus a. Now equate it to 0 and find out the critical points here. Your dt by dx is equal to 0. So minus 2b squared by a squared into a minus x the whole squared into 2x plus a is equal to 0 you get. So what's the value of x equal to here? X is equal to a and x is equal to minus a by 2. This is what you have here. Now coming over to this, now I'll have to check. Okay, that is one problem actually under this application of this. I'll have to check whether this critical point will be feasible or not. So x is equal to a you get here. So you know y squared is equal to b squared by a squared into a squared minus x squared you get. When I substitute x is equal to 0, what will I get here? Y is equal to 0 you will get. So that part is not possible here. Got it? So what is the other one you have here? X is equal to minus a by 2. So I can only take x is equal to minus a by 2 here. Got it? So this is the only critical point in this case. Now again I'll have to find the second derivative, that is differentiated again with respect to x. What will I use here? I'll have to use a UB formula. So it's minus 2b squared by a squared into a minus x the whole squared into differentiation of 2x plus a is what? 2 plus 2x plus a into differentiation of a minus x the whole squared. What will you get? 2 into a minus x into differentiation of a minus x is what? It is equal to minus 1. You understood? Okay. Now your d squared t by dx squared at x is equal to minus a by 2. So at x is equal to minus a by 2, when I substitute it, what will you have here? It's minus 2b squared by a squared into 2 into minus of minus, it's nothing but a plus a by 2 the whole squared. Okay, now here if you see I've got a minus sign here, so minus sign I put 2 into minus a by 2, so of course it gets cancelled. So what happens here? Minus a plus a will become 0. So this whole thing it becomes 0. So this is positive and this is negative. So positive into negative will give you only negative. So what can I write the answer to be? It's nothing but less than 0. Once again I'm telling you, don't do the calculation fully and then show it as less than 0 and waste your time here. It's enough if you say that it's said to be less than 0. So what can I write here? Your area is said to be maximum when x is equal to minus a by 2. And I'll have to find out the maximum area. So what is your maximum area? So area, you know what's the formula? A squared is equal to y squared into a minus x the whole squared. In the beginning we got this relation. So here it's nothing but b squared by a squared. So this only we wrote it as b squared by a squared into a squared minus x squared into a minus x the whole squared. So here I have written it as b squared by a squared into a squared minus x squared. Your x is equal to minus a by 2. When I square it, you will have it as a squared minus a squared by 4 into a plus a by 2. So here we have written it as a plus a by 2. So what will you get? B squared by a squared into 3a squared by 4. Here if you see it is 3a by 2 the whole squared will give you what? 9a squared by 4 you get. So here it is 27 a squared b squared divided by 16 square units. So I'll have to find out the area. So to find out the area, what I do here is I find the square root here. So this one I can write it as 3 into 9. When I take the square root, it becomes what? 3 root 3 a b divided by 4 square units. Okay. The ninth question, a tank with rectangular base and rectangular side open at the top is to be constructed so that its depth is 2 meter and volume is said to be 8 meter cube. If building a tank cost rupees 70 per square meter for the base and rupees 45 per square meter for sides, what is the cost of the least expensive tank? Okay, so here in this case, so what is that given here actually? Your length, breadth, the depth of the tank is nothing but the height actually here. Okay, so here you just imagine a tank like this, okay, a rectangular base here. So this is a rectangular tank. You just imagine this part is open here actually here. The height of the tank is given, that is the depth of the tank is given. What is the depth of the tank here? The depth of the tank is nothing but equal to 2 meter it is given here. Okay, so this is the base. So this is the base you have here. So in this case this is the base, okay, base of the tank. This is what you have here, the base. So construction of the base, if you see here, it is rupees 70 here, and construction of the side, construction of these sides. So how many sides are there? 1, 2, okay. So here if you see, this is one side, this is the second side, the underneath one, that is the third side, and this is the fourth side. So there are 4 sides actually here, and there is only one base. Okay, and this top, if you see here, it is open. So whatever is filled in, that is why they have given us the volume there. So the volume is equal to 8 meter cube. So here you just take here, x is said to be the length, y is said to be the breadth, h is said to be the depth here. And what else is given? Volume is equal to. I'll have to find out what is the cost of the least expensive tank here. So to find out the cost of the least expensive tank, I need to find out the area. Only then I can find out the cost of the least expensive tank. So what is your area equal to here? Area of the rectangle is equal to length into breadth. So I have just written it as x into y. So what is this actually here? Area of the rectangle is equal to length into breadth I have taken. This is nothing but the area of the base. So why is that I have taken the area of the base here? Now you see this part, actually here it's nothing but a rectangle. The base is actually a rectangle you have here. Okay, so the base is a rectangle. So the area of the base is nothing but, I have used this formula. Area of the base is equal to L into B, which is equal to xy meter square. That is, length I have taken it as x and breadth I have taken it as y. Okay, now I will have to find out the area of the four sides actually here. You would have studied in your lower class area of the wall, okay, which contains four sides actually here. So what is the area of the wall which contains four sides actually? It is equal to 2 into twice of the length plus twice of the breadth into the height of the, okay, into the height of the wall or the box, whatever it is. That is what I have written here. So here I have written it as 2 into L plus B into height. Okay, so here this is the formula again here. So now I'll have to find out what is the total cost. No, so how do I find out the total cost? First of all, I'll just write this as 2 into x plus y, and what is your height equal to here? 2. So I can write it as 4 into x plus y you have. So what is the total cost? So to construct the base, how much rupees is needed actually? 70 rupees is needed. To construct the sides, if you see here, 45 rupees is needed here. So the total cost is equal to 70 into the base area plus 45 into the sides of the wall, okay, that side area here. So 45 into 4 into x plus y. This is what you have here. Okay, only till this part it's a little, what is it here? You will have to know correctly here. After that it's very easy. So you can write it as 70xy. 45 into 4 is 180 into x plus y. So already I have told you, if you have in terms of x and y, my problem is either I must bring it in terms of x or in terms of y. So for that only something else is also given to us in the question. What else is given here? The volume is given. What is the volume of a rectangle here? It's length into breadth into height, which is equal to 8. So here xy into 2 is equal to 8. So I can write xy is equal to 4. So what is your y equal to here? It's equal to 4 by x. So what is the cost equal to here? 70 into xy. So what is your 70 into xy? What will you have here? It's nothing but equal to 4, because xy is equal to 4 plus 180 into x plus, what's the value of y here? Y is nothing but 4 by x. So you have got the equation. So the remaining, it's very easy, because we are going to apply only the second derivative test. I am going to differentiate it with respect to x, etc. Okay. So here your cost is equal to 280 plus 180 into x plus 4 by x you have got here. So differentiating it, your dc by dx is equal to 0 plus 180 into differentiation of x is what? 1, and differentiation of 4 by x. So you know what is d by dx of 1 by x. What is d by dx of 1 by x? That's nothing but equal to minus 1 by x squared you have here. So I will have it as 4 into minus 1 by x squared, that I have written it as minus 4 by x squared. Okay. Now we will find out the second derivative here. 180 into differentiation of 1. What is differentiation of 1? That's nothing but 0. And what is differentiation of 1 by x squared here? So here your d by dx of 1 by x squared. So when I take it to the numerator, you will have it as x power minus 2. D by dx of x power minus 2. What is d by dx of minus 2 here? Minus 2 x power minus 3. Otherwise I can write it as minus 2 divided by x power 3. This is how I can write here. So you will have it as 180 into, this becomes 0, minus 4 into minus 2 by x squared. So what will you have? 180 into 8 by x cube. Got it? Now we will find out the critical point here. Your dc by dx is equal to 0. 180 into 1 minus 4 by x squared is equal to 0. So you will get 1 minus 4 by x squared equal to 4. 0 here. So 4 by x squared is equal to 1. So what is your x squared equal to here? It's x squared equal to 4, and your x is equal to plus or minus 2. So what will you get here? X is equal to 2 here. Now what is your second derivative? That's nothing but equal to 180 into 8 by 2 cube. So naturally it is positive and it is greater than 0. Therefore what can I say here? The cost is said to be minimum at x is equal to 2. And what is the least cost you get? It is equal to 280 plus 2 plus 4 by 2, which is equal to 284. So here the answer is equal to 284. So what is the minimum cost required to construct that tank? It is equal to rupees 284. So the 10th question, the sum of the perimeter of a circle and a square is said to be equal to k, where k is some constant. Prove that the sum of the areas is said to be least when the side of the square is double the radius of the circle. So what is given to us actually here? The sum of the perimeter is equal to k. That is given to us here. What is to be proved actually here? That it is said to be of least area when the side is equal to twice of r. So when the side is equal to twice of r, I'll just take it to be equal to xx in this case. Okay, here we'll just take it to be equal to xx here. So in that case, what will you have here actually here? So here 4 times, what is the perimeter of a square? It's nothing but 4x you will have. And what is the perimeter of a circle? What will I get? That's nothing but the circumference of a circle you get here. Okay, so what is this area? Circumference of a circle? What will you have here? It will be nothing but 2 pi r. So it's nothing but 2 pi r plus 4x, which is nothing but equal to k. Okay, so here this is what you have here. Okay, so here it is equal to 2 pi r plus 4x is equal to k, because the sum of the perimeter is equal to k. That is given to us. Now here when I write, what will I get in this case actually here? You have it as k minus 2 pi r is equal to 4 times of x you will get. So what is your x equal to? K minus 2 pi r divided by 4. We'll keep it as aside. Now they have asked us to show that it has got the least area. So here what is the area of a circle? It's equal to pi r squared. What is the area of a square? It's nothing but plus x squared. It's nothing but side squared. What is your side equal to here? Side is nothing but equal to x. So you know what is this x equal to? What is this x equal to here? K minus 2 pi r divided by 4 the whole square. So you've got your area in terms of, what is it here actually here? In terms of r throughout, pi r squared plus k minus 2 pi r by 4 the whole square. So it's enough if I show by the second derivative test that it is said to be minimum. Okay. So you have your area to be equal to pi r square plus k minus 2 pi r divided by 16 the whole square. Now differentiating it with respect to r, what will you get here? It's 2 pi r. Now here I'll have to apply the chain rule. So it's 2 into k minus 2 pi r into differentiation of this will give you what? Minus 2 pi divided by 16. So here if you see 2 and this gets cancelled here. So you're left with 4 here. So it's 2 pi r minus pi by 4 into k minus 2 pi r. This is what you have here. So what is your dA by dr equal to here? dA by dr is nothing but equal to 0. Got it? Why I equated to 0? To find out the critical point here. So when you find the critical point, what will you get? 2 pi r is equal to, what will I have here? It is pi by 4 into k minus 2 pi by r. Because when I equate this to 0, this goes to the other side. So you're left with pi by 4 into k minus 2 pi r. Now cross multiply it here. So what will you get here actually? Or when you cross multiply in this case, you have it as 4. So it's nothing but 8 into, what will I have here? It's nothing but pi r. Okay, so you have it as 8 pi r you have here. Okay, which is equal to k minus 2 pi r. Okay, so here this is what you have here. Now taking it to the other side, what will happen here actually here? This k alone is there. When I bring this here, you will be left with 8r plus 2 pi r is equal to k you have here. When I take r outside, you are left with 8 plus 2 pi, which is equal to k. This is what you have here. So what is your r equal to here? Your r is nothing but equal to k divided by 8 plus 2 pi. Okay, so here this is what you have in this case. Of course here if you see this pi and pi, it gets cancelled. That's why you get it as 8r you have here. Got it? So r is equal to k by 2 plus 8 plus 2, 8 plus 2 pi. Now we'll find out what is d squared a by dr squared. What is d squared a by dr squared here? Differentiating your dA by dr. When I differentiate this, what will you get? It's 2 pi. And now here when you differentiate it, it's minus pi by 4. Differentiation of k is 0 into minus 2 pi. So you are left with what? 2 pi plus 2 pi square divided by 4. It is said to be positive and it's greater than 0. Therefore, what can I say here? Area is said to be minimum. This is what you have here. Got it? So you have shown that it is said to be, area is said to be minimum. So when is your area minimum actually here? When the side of the square is double the radius. So I'll have to prove that part actually here. So we'll see how we can prove that. So initially you would have got this relation 4x plus 2 pi r is equal to k. Okay, 4x plus 2 pi r, that is sum of the perimeter is equal to a constant. You know what is k now. What is k here actually here from this part? K is equal to 8 plus 2 pi r. That is what I have equated bracket here, it is 8r plus 2 pi r, which is equal to 4x plus 2 pi r you get. So here if you see, it gets cancelled. So you are left with 4x equal to 8r. So what's the value of x here? X is equal to twice the radius of the circle. So here when the area is said to be minimum, when the side of the square is said to be equal to twice the radius of the circle. Okay, so understood? Yes. Now here the next one, another important question, the 11th one. A window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is said to be 10 centimeter. Find the dimensions of the window to admit maximum light through the whole opening. This is what I'll have to find out. So what is given here? A window is in the form of a rectangle surmounted by a semicircular opening. The total perimeter of the window is said to be 10 centimeter. So the total perimeter of the window is said to be 10 centimeter. Find the dimensions of the window to admit the maximum opening through the whole opening. So what is it I'll have to find out? Find the dimensions is what? The length and breadth I'll have to find out there, as well as what is it actually here? To admit maximum through the whole opening. Okay, maximum area. So here this is what I'll have to find in this case. So this is a figure we have taken here. So this is a rectangle window surmounted by a semicircular opening here. So what is the length you will get here? It's nothing but x. What is the breadth you have here? It is equal to y. Now this is a semicircle. So what is this radius of the semicircle? What will you get here? It's nothing but equal to x by 2. So that is what I have written here. So here in this case, a perimeter is equal to 10 centimeter. That is given to us. So perimeter is equal to 10 means what will I write here? Perimeter is equal to. So what will I have here? Perimeter is nothing but the circumference only you have. So you have only one length here. It is x, plus you have 2 breadth, so it is twice of y, plus this semicircle, this portion comes off. That is why I am not taking twice of x here. So what is the perimeter or the circumference of the semicircle? You know the perimeter, the circumference of a circle is what? It is equal to 2 pi r, you know. So for a semicircle, what will be the circumference you get? It will be nothing but pi r. So that's what I have written it as 1 by 2 into 2 pi r, just half of that, because it's only a semicircle. So you know what is your r equal to? X by 2. 2 and 2 it gets cancelled, so it is x plus 2y plus pi into x by 2 you get. What is the perimeter equal to here? Perimeter is equal to 10, which is equal to x plus 2y plus what will I get here? It's nothing but equal to pi x by 2 you get. So here I am going to write my y in terms of x, because further I need to differentiate it with respect to x here. So keeping it as it is and bringing it to the other side, you have it as 10 minus x minus pi x by 2 is equal to 2y. So what's the value of y? Okay, now you take the LCM here. It's 20 minus 2x minus pi x by 2. So y is equal to 20 minus 2x minus pi x divided by 4 you get. So here I'll have to find out the maximum light which can fall through the opening. So in other words, I'll have to find out this maximum area. So you know what is the area of a rectangle? It's length into breadth. That's nothing but x into y. Area of a circle is what? Pi r squared. So what is the area of a semicircle? It will be nothing but just half of that. So it's pi r squared by 2. So it's x into, here when I substitute y, you will have it as 20 minus 2x minus pi x by 4 plus pi into x squared divided by, what will I get here? It's nothing but 4, because what is your r equal to there? R is equal to x by 2 the whole squared you will get here. So it is x squared divided by 4. You already have a 2 there. So it's nothing but x squared by 8. Now when you multiply this, it's 20x minus 2x squared minus 5x squared by 4 plus 5x squared by 8. So differentiating it with respect to x, dA by dx is equal to 20 minus 4x minus 2 pi x divided by 4 plus 2 pi x divided by 8 is what you have here. Okay, so we'll find the second derivative also here. So when I find the second derivative, it's minus 4 minus 2 pi divided by 4 plus what will I get here? 2 pi by 8 you will get. So 2 pi by 8 it gets cancelled here. So I am left only with pi by 4. So the LCM is just 4 here. It's minus 4 minus 2 pi plus pi. So you will get it as minus 4 minus pi. So naturally it is said to be less than 0. From this itself I will know it is maximum. But I need to know the dimensions at what the lighting is said to be maximum here. So I need to find out the value of x and y. So how can I find out the value of x and y? By equating this to 0. So equating it to 0, 20 minus 4x minus 2 pi x by 4 plus pi x by 4 equal to 0. So here when I cross multiply, this is nothing but equal to 0 you get here. So it is 20 minus 4x minus 2 pi x plus pi x is equal to 0. So here again 0 into 4 is nothing but equal to 0. So you are left with 20 minus 4x minus pi x is equal to 0. So I'll just take the x terms alone to the right hand side because I need what is x actually, are the dimensions there. So here you will have it as 20 is equal to 4x plus pi x, where you have x into 4 plus y pi. So what is your x equal to here? X is equal to 20 divided by pi plus 4. Okay, you have got this here. So now I need to substitute it in y here. You know that I already told you your second derivative is nothing but less than 0. So it is maximum. I'll have to substitute my x in the first one. What's the first equation you get here? The first equation is nothing but 20 minus 2x minus pi x by 4. I'll have to substitute it in that actually here. So when I substitute it, what will I get? Y is equal to 20 minus 2 into 20 by pi plus 4 minus pi into 20 divided by pi plus 4 divided by 4. This is what you have here. So cross multiply 20 into pi plus 4 minus 40 minus 20 pi divided by, what will I get here? 4 into pi plus 4. So what will I get here? 20 pi plus 80 minus 40 minus 20 pi. It gets cancelled. You are left with 40 by pi 4 into pi plus 4. What is it equal to here? It gets cancelled. So you are left with 10 by 4 plus pi. So what are the dimensions you get here? X is equal to 20 by pi plus 4 and y is equal to 10 by pi plus 4. So when the area is maximum, what is the dimension of the what is it here? The window, it is 20 by pi plus 4 and 10 by pi plus 4. You understood? Yes. Now the 15th question here. Show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is said to be equal to 4r by 3. This is what is given here. So show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius is said to be equal to 4 by 3 in this case. So here there is a sphere, a right circular cone is said to be inscribed in it actually here. I'll have to show that it has got maximum value, and what is it here? The radius of the sphere is nothing but equal to 4r by 3. So I have drawn the figure here. You have a sphere, a right circular cone is said to be inscribed in it actually here. So in this case, this is the height of the cone. Your AD is said to be the height of the cone, and you know that R is said to be the radius of the sphere, and I have taken this height to be equal to x. This triangle here, we have taken it to be equal to x here. So what will I get here actually here? Your AC plus CD is nothing but equal to the height of the cone. I have taken it as h. And here if you see, this is the radius of the sphere. So I need to find out what is BD. What is your BD actually? Your BD is nothing but the radius of the cone you will get. So by using this Pythagoras theorem, what will I get here actually? Here your r squared is equal to x squared plus BD squared you will get. So here you will have it as r squared minus x squared is equal to BD squared. That's nothing but your radius of the cone. That is what I have written it as square root of r squared minus x squared. Now what is your height equal to? Height of the cone, it's nothing but r plus this distance you will have here. So it's nothing but equal to r plus x, because from the center to the circumference this is nothing but your radius. This I have taken it to be equal to x, so it is r plus x. That's the height of the cone. So I'll have to show that it's a maximum volume. So what formula I will be using here? Volume of a cone, which is equal to 1 by 3 into pi r squared h, which is equal to 1 by 3 into pi into, what is your radius of the cone in this case? It's just square root of r squared minus x squared. So when I square it, you will have it as r squared minus x squared into height. That's nothing but equal to r plus x. See, I cannot write it as h there because that's another variable you will have. So I'll have to bring it in terms of r, okay, and x in this case. So now differentiating it with respect to x. dv by dx is equal to pi by 3 into, apply the uv formula here. So when I apply the uv formula, what will you get? R squared minus x squared into 1 plus, what is the next one you get here? R plus x into differentiation of this will give you what? Minus 2x. This is what you have here. Got it? Now this one I can write it as r plus x into r minus x. This is what you have here. So here if you see you've got r plus x, here also if you see you've got r plus x. So it's pi by 3 into r plus x into, here you have it as r minus x minus 2x. So what have you got here? It's r minus 3x. So it is pi by 3 into r plus x into r minus 3x. This is what you have here. Now we'll find the second derivative also. Again I'll have to apply the uv formula. It's pi by 3 into r plus x into differentiation of this is what? Minus 3 plus r minus 3x into differentiation of r plus x is what? It's nothing but equal to 1. So you have it as pi by 3 into minus 3r minus 3x plus r minus 3x. This is what you have here. So what is that? Pi by 3 into minus 3r plus r is what? Minus 2r. Here if you see in this case, it is equal to minus 3x minus 3x you will have here. So what is that you have here? It is equal to minus, what will you have? 2r, okay, minus 4x. This is what you have in this case, okay. Minus 3r. So here if you see, it's minus 2r, and here you have it as minus 4x, okay. So here this is what, sorry, it's minus 6x you will get. Yeah, it is equal to minus 6x. Okay, ma'am. Now we will find out the critical point, equating it. dv by dx is equal to 0. So pi by 3 into r plus x into r minus 3x is equal to 0. So you will have it as r plus x into r minus 3x is equal to 0. Of course, x is equal to minus r you get here. So x is equal to minus r, if you see here, it's not applicable because it is said to be negative. So what is the other point I can take here? X is equal to r by 3. Now when I substitute it here in d squared v by dx squared, which is equal to pi by 3 into minus 2r minus 6 into, what will I get here? R by 3. Of course it is said to be only less than 0. Therefore what can I say here? It is said to be maximum. So what is the volume actually? The volume is said to be maximum. But there is one condition given there. The volume is said to be maximum and the radius must be equal to 4r by 3. So we will check what is the radius there. Sorry, not the radius, the volume is maximum and the altitude of the cone, that is the height of the cone, must be equal to 4r by 3. So here you know what is the height of the cone equal to? R is equal to x, h is equal to r plus x. What is your x equal to? Your x is equal to r by 3. So you will get it as r plus r by 3, that's nothing but equal to 4r by 3. So here again by mistake I told it as the radius of the cone. It's not the radius of the cone. The altitude of the cone must be equal to 4 times the 4 by 3 times the radius of the cone there. So what's the altitude of the cone you have there? Actually your altitude of the cone is nothing but equal to h you will have here. So it is equal to 4 by 3 times the radius of the sphere. Got it? Yes. Now here the 17th question. Show that the height of the cylinder of maximum volume, which can be inscribed in a sphere of radius r, is said to be equal to 2r by 3. Also find the maximum volume. Show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r. So what is the radius of the sphere given here? It is equal to r. I'll have to show that the height must be equal to 2r by 3. This is what I'll have to show in this case. That is the height of the cylinder must be equal to 2r by 3 here of maximum volume. So here I have just drawn a sphere in this case, and we have a cylinder. Okay, it's a cylinder here. And of course in this case the whole thing here, if you see from this will be nothing but the radius of the sphere. You know it is the radius of the sphere you have here. So the whole height of the cylinder I have taken it to be equal to 2x. That I have taken it as capital H. Okay, capital H is equal to 2x you have here. Now if this is whole thing is equal to 2x, what is this distance you have here? It will be nothing but equal to x. Now here when I take this triangle by Pythagoras theorem, I can say that the radius of the cylinder is nothing but equal to square root of capital R squared minus x squared by Pythagoras theorem. For the previous one I told you how to do the same way. Now I'll have to show that it has got maximum volume actually. So I'll have to take the volume of the cylinder. What is it equal to? Pi r squared h. Here my height of the cylinder I have taken it to be equal to capital H here. So it is equal to pi into r squared minus x squared. And what is your h equal to? H I have taken it to be equal to 2x. So I have just written it as 2x here. So it's pi into what, when I multiply it, it is 2r squared x squared minus 2x cube. Okay. Now differentiate it with respect to x. When you differentiate it, it's pi into 2r squared minus 6x squared you get. Got it? So again differentiate it. So when you differentiate it, what will I get? It's equal to pi into, what will I have here? It's nothing but equal to minus 12x. Okay, so here you have it as minus 12x, pi into minus 12x. This is what you have here. Okay, what's the next step I'll have to do here? I'll have to find out the critical point. So So to find the critical point, I'll have to equate the first derivative to 0. So you are left with pi into, what will I get here? It's r squared minus 2r squared minus x squared is equal to 0. So you get 2r squared minus 6x squared is equal to 0. You get 2r squared is equal to 6x squared. So what will you get? You will have it as x squared is equal to 2r squared by 6, which is equal to r squared by 3. So what will I have? X is equal to r divided by root 3. Okay, so here this is what you get here. X is equal to r divided by root 3. So here you have got the value of x. Now we will see whether it is maximum or minimum here. Your d squared v by dx squared at x is equal to r by root 3 is what? Pi into minus 12x you will get. So it is pi into minus 12 into r by root 3. You have a minus sign here, so it is less than 0, and obviously it is maximum. So I need to find out the height of the cylinder. So you know what is the height of the cylinder equal to? What is it equal to here? 2x I have taken here, which is equal to 2r by root 3, because you know what is your x here? What is your x in this case? Your x is equal to r by root 3. Therefore, you write it to be equal to 2r by root 3. Got it?